Hello, good morning, Happy New Year, and welcome back to Refactoring Bitcoin. Before we continue where we left off last year, I want to say a few words about C++ terminology. This is a function. Other programming languages use different terms for the same thing, like procedure or subroutine, but in C++ we use the same term that's also used in the C programming language. In C++, functions can be inside a class or a struct. This is what we call a member function. They can also be outside a class or struct. This is what we call a free function. Don't use the term global function unless the function is actually implemented at the global namespace, which is not something that is recommended. If you have a free function inside the same namespace as a class and the class is passed as an argument, we consider that function as part of the class. We say that the function is a non-member function of the class. But now we want to have a look at member functions. Member functions can be virtual. Virtual member functions are extension points for runtime polymorphism. A class that has at least one virtual member function is called a polymorphic class or base class. Derived classes can override functions from the base class. Member functions can also be pure virtual. This is shown here with the equal 0. That means no implementation is provided in the base class, but derived classes have to provide an implementation, otherwise they cannot be instantiated. A class that has a pure virtual member function without an implementation is called an abstract class. So derived classes that do not override the pure virtual member functions from the abstract base class are themselves abstract and cannot be instantiated. Only if a class overrides all pure virtual member function, it can be instantiated and is called a concrete class. So those were the terms that I wanted to present today. But those terms are often misused. The attributes are mixed and used wrongly. For example, you may hear or read about a virtual class. We can guess what is actually meant here, right? So when someone says virtual class, what they probably mean is a polymorphic class. Remember that functions can be virtual, and a polymorphic class is a function, polymorphic class is a class that contains at least one virtual member function. Another misused term is the term abstract function. Again, classes can be abstract, but functions, they can only be virtual. A class is abstract if it contains at least one pure virtual member function. So when someone says abstract function, what they probably mean is a pure virtual member function. Another term that you hear quite often, but it's actually not defined in C++, is the term method. This is a term that comes from other languages like Java or C#. And in those languages, a method is always inside a class. Also, derived classes can override methods. That means the closest thing in C++ would be a virtual member function. So when someone says method, we can guess what they actually mean is a virtual member function. But if someone uses the term virtual method, we have to rethink that assumption, right? Because when they explicitly point out virtual method, we are no longer sure what they actually mean by method. So we can say that a virtual method should be a virtual member function, but method could be a virtual member function, could also be just a normal member function. It's better to avoid those terms because it just adds confusion. you better use the C++ native terms member function and pure virtual member function and virtual member function. But the confusion is perfect if someone uses the term global method. Well, what do they mean by method now, right? We can guess what they actually mean is a free function when they say global method. But this is a tricky one. A template method. What is that? Well, the book Design Patterns from the Gang of Four contains a design pattern called template method. The template method is used to define a skeleton of an algorithm in an operation where some steps are deferred to subclasses. We can see here the example from the book is a class view. That's a abstract base class because it contains a pure virtual member function called doDraw, which is protected. And then it has this public member function called draw, which internally calls doDraw after setting a focus, after establishing some preconditions, establishing some invariants of the class, and also calling a reset function at the end of the algorithm. If you implement the template method design pattern in C++, it's perfectly fine to refer to it as that name, template method, but just keep in mind that this has got nothing to do with C++ templates. So what we've shown here, this is a function that takes a template argument. This is not a template method. The correct term for this is also not template function. The correct term for that is a function template. So keep in mind, when someone uses the term template method, depending on the context, it's either a template method design pattern, therefore we use the capital casing here because it's a name, or could they actually refer to a function template? That needs to be decided based on context. Another tricky term that is used this is taken over from other languages, is the term interface. So what does that mean? Interface in C++ is not a language construct. Languages like Java or C#, they have a keyword interface, and an interface in those languages is considered whatever is defined by that keyword. But C++ does not have such a keyword. When we say interface in C++, what we mean is the definition of the term in the general software engineering sense. That means an interface could be anything that another piece of code is allowed to rely on. And that includes syntax, the semantics, the linkage, the calling convention, layout guarantees, the overload sets, the visibility or the accessibility rules, right? We distinguish in C++ between the public interface, the protected interface of a class. Yeah. So here is an example that we've shown previously, the widget with the non-member function called foo. When I give you a widget, what can you do with that widget? Well, what you can do is you can pass it to the function foo, and therefore the function foo is part of the class widget's interface. Right? This is how we consider an interface in C++. We also have seen this code example before. This was the template method example. Here you see, when I give you a view, what can you do with the view? Well, you can call the function draw, the member function. Therefore, draw is considered part of the interface. Can you also call the doDraw function? No, you cannot, because it's protected. Therefore, the doDraw function is not part of the class interface, at least not the public interface. If you have the mindset if you come from Java or C# and you consider an interface as something that only contains virtual member functions, you might be surprised to see that the virtual member function is actually not part of the interface. And in C++, we actually prefer interfaces that do not have any virtual functions. We want to keep the polymorphic behavior as an implementation detail. So that was it. That was what I wanted to present today. Remember to beware of false friends. A gift in German is not the same thing as a gift in English. And in the same sense, an interface in C++ is not the same thing as an interface in Java. Watch out for misused terms like method or pure abstract interface or anything like that. If you come across such a term, when you see that someone uses such a term, please point them towards this video so they can learn what the actual C++ terminology is. And it's better to use actual C++ terminology in documentation to just avoid confusion. I know that many programmers, but also LLMs get this wrong. So yeah, we have a long way to go. Thanks for watching. If you like this video, please subscribe to get notified for newer videos. We will go into much more detail about proper interface design in C++. Well, thanks for watching and goodbye.